Learning Goals. Welcome to this learning session on Introduction to Scatter Diagrams and Bivariate Data. In this course, we shall address Introduction to Scatter Diagrams, Understanding Bivariate Data, Plotting Scatter Diagrams, Interpreting Association and Correlation, Examples and Real-World Applications. There will be a quiz at the end to test your knowledge.
Introduction to Scatter Diagrams. Scatter diagrams are graphical tools used to visually represent the relationship or association between two different sets of numerical data. They allow us to quickly observe patterns and trends that might not be obvious from raw data alone. The primary purpose of a scatter diagram is to determine if an increase or decrease in one variable corresponds to an increase or decrease in the other. For example, a scatter diagram could show if there's a relationship between the amount of fertilizer used and crop yield, or between study hours and exam scores. These diagrams are widely applied in various fields, from scientific research to business analytics, to identify potential correlations. For instance, economists might use them to study the relationship between interest rates and consumer spending, while biologists could analyze the correlation between an animal's age and its weight. Understanding bivariate data and variables. Scatter diagrams are specifically designed to represent bivariate data, which refers to data involving two different variables. The goal is to examine how these two variables interact or influence each other. When constructing a scatter diagram, it is crucial to distinguish between the two types of variables, the explanatory independent variable and the response dependent variable. The explanatory variable is the one that is changed or controlled, and its values are plotted on the horizontal x-axis. Conversely, the response variable is the one that is observed to change in response to the explanatory variable or depends on it. Its values are plotted on the vertical y-axis. For instance, in a study of plant growth, the amount of water given to a plant would be the explanatory variable, and the plant's height would be the response variable, as height is expected to depend on water intake. Scatter diagrams visually represent the relationship between two variables. Accurate plotting is crucial for correct interpretation. To plot a scatter diagram, each pair of data points, explanatory variable, response variable, is represented as a single point on the coordinate plane. The explanatory variable determines the horizontal position, and the response variable determines the vertical position. Accurate plotting is essential for correctly interpreting the relationship between variables. Each point on the diagram corresponds to a unique observation, such as a specific student's study hours and exam mark, or a particular plant's water intake and height. The collection of all these points forms the scatter diagram, revealing the overall pattern. For example, if a student studied for 5 hours and scored 80%, this would be plotted as the point 580. If another student studied for 7 hours and scored 75%, it would be plotted as 775. Interpreting association and correlation. Once plotted, a scatter diagram allows for the interpretation of the association between the two variables. This association describes the general pattern or trend that the data points follow. There are three main types of association: positive, negative, and no association. A positive association occurs when the response variable tends to increase as the explanatory variable increases, forming an upward-sloping pattern. Conversely, a negative association is observed when the response variable tends to decrease as the explanatory variable increases, showing a downward-sloping pattern. If the points on the scatter diagram are widely scattered with no discernible pattern, it indicates little to no association between the variables. The strength of an association is determined by how closely the points cluster around a straight line. The tighter the cluster, the stronger the correlation. A perfect correlation, where all points lie exactly on a straight line, is rare in real-world data, but represents the strongest possible association. Worked example: study hours and marks. Let's revisit Katie's data on student study hours and exam marks to apply our understanding of scatter diagrams. The data shows that students who spent more hours revising generally achieved higher marks. In this scenario, the time spent revising is the explanatory variable, as it is the factor that Katie is observing to see its effect. The mark % achieved in the exam is the response variable, as it is expected to depend on the time spent studying. When these points are plotted, they tend to cluster in an upward-sloping pattern, indicating a positive association. The closer the points lie to a straight line, the stronger this positive association is, suggesting that increased study time is strongly linked to improved exam performance. This type of analysis can help students understand the direct impact of their efforts. Real-world application: temperature and rainfall. Consider AB's investigation into the relationship between temperature and rainfall. This is a classic example of how scatter diagrams are used in meteorology and environmental science to understand climatic patterns. In this context, temperature, degrees Celsius, would typically be considered the explanatory variable, as changes in temperature can influence atmospheric conditions, leading to rainfall. Rainfall, mm'd, would then be the response variable, as it is the outcome being measured. If Abby's scatter diagram shows a downward trend, it suggests a negative association. As temperature increases, rainfall tends to decrease. This could be indicative of a dry season or a specific climate pattern. Conversely, an upward trend would suggest that higher temperatures are associated with more rainfall, perhaps in a tropical climate. Analyzing such diagrams helps scientists predict weather patterns and understand climate change impacts.
Summary. Well done! You have completed the course Introduction to Scatter Diagrams and Bivariate Data. You should now be familiar with Introduction to Scatter Diagrams, Understanding Bivariate Data, Plotting Scatter Diagrams, Interpreting Association and Correlation, Examples and Real-World Applications. Should you need to revisit any of the topics in this course, please use the menu at the bottom of the screen.